All right, cool. So the recording's on, guys, so you don't have to worry about that. I think we finished this one. So you guys can always watch the YouTube videos again. Well, obviously, if you're listening to this, you're probably already watching the YouTube videos. But the main idea here was to do a box method and to do one of each. So there was a duplicate. I forget what the duplicate was. I want to say the duplicate was m minus 1, but we only include that once on an LCM, lowest common multiple. All right. So again, you guys can watch the video if you'd like. I'm just going to skip around in here. These are usually helpful because they describe what we have to do here. And they really go into this even more, and they use these nice little organizing charts. So I know I never watched these in class because we never had time. We still technically don't, even though now it's going to be a module every week. But these are really useful. It really goes over it and it highlights everything. So if you guys are just trying to rush through these, just take some time, especially now that the class is at a more leisurely pace. So we did we do this one? Can someone remind me if we did this one? I forgot because I've done these tutorials so many times. I want to say we did. No. Okay, cool. Thank you. Good thing you mentioned that. All right. So what we're going to do for this one, luckily they were nice enough to factor out a GCF for us. So this was probably in the form of 2x plus 2, but they're like, we'll be nice to them and we'll factor it out. So they were nice and they did that. The next thing we have to do is we have to do a box for each of these. And I'm going to use different colors. So this is going to be one box. This is going to be another box. Let's do this box right here. All right. So what we're going to do here is always put your first number in the first box. Your last number goes in the last box. And your middle number kind of goes right here. It's a reminder that this box and this box need to add up to each other. So this, how do we get x squared? Well, that's x times x. X times x is x squared. How do we get negative 2x? So that's negative 2 times positive 1. The reason why I'm doing negative 2 instead of positive 2 and negative 1, because negative 2 times positive 1 is negative 2. But guess what? 2 times negative 1 is also negative 2. So why did I pick negative 2? Well, I knew that my middle number was negative. So I had a feeling if I do this, negative 2x and then x, technically 1x, if I added these two together, I would get that negative 2. All right. That's quite a story. So this will add up. So I can change this to 2x plus 1 over x minus 2 x plus 1. So now I'm going to focus on the green box. So this green box over here. If you guys don't like the colors or you guys think I need to use more colors, let me know. Because I do realize sometimes I forget to mix the colors up. Like, for example, this should technically be in black. And I forget to change that. That way you guys know which one corresponds with which one. Green is good. That's your comment. Not, oh, the colors help. It's like, yeah, I like green. 2 And I'm going to put my little reminder right here that they need to add up to negative 3x. I'm going to do x. X. I need a positive 2, but I need a negative 3. So how would I do that? Well, what I'm going to do here is, guess what? 2 negatives make a positive. And luckily enough, if we add those two together, we're going to get this negative 3x. So I'm going to leave the top the same. And the bottom is going to be this x minus 1, x minus 2. Well, one thing that I noticed right off the bat, now that I have this reduced, is now that everything's being multiplied, there is additions in the parentheses, but now that everything's being multiplied, these two match up. So I'm going to cross these two out. So now I don't have to worry about this plus 1 anymore. It's gone. But this one has an x minus 2 and this one has an x minus 1. So what I have to do now is I'm going to change this to 2 x minus 1 over this x minus 2, which is what we're taking from over there. And I'm also going to multiply this by x minus 1. The reason why I do this is because now our bottoms are exactly the same. I kind of mix them around, but just remember with multiplication, you can always mix them around. That she makes a good point in that chat, Sammy. And I'm sorry for everyone else watching this on YouTube and going like, I don't know what they're talking about. So now that I have this the same, this turns into 2x minus 1 minus x over x minus 2 times x minus 1. They're the same denominator, so I can make them exactly the same here. So now I can distribute and I get, so I'm going to distribute this. And by distributing this, I get 2x minus 2. I'm going to bring down my minus x. And remember, these are the same, so I'm not going to change that. This is x minus 1. I can simplify this by doing my like terms. So since Nelson liked green, I'm going to go with green. So 2x minus x. That's going to be x minus 2 over x minus 2 x minus 1. Oh, wait. This x minus 2 are the same. I can cancel them out. So I'm going to leave a placeholder 1 on the top. And there's going to be x minus 1 at the bottom. So again, guys, this is a lot of work. Apparently, though, they didn't want me doing all the cancellations because I don't even see the answer here. Did I miss something? Well, you guys are really distracted right now. Let me check my work here, but I'm pretty sure I did everything right. X minus x plus 1, x plus 1 canceled. This x minus 2, x minus 1. Okay. Multiply the top and bottom, x minus 1, x minus 2, x minus 2. Should be right, but it looks like the book didn't do it all the way simplified. 3x. Oh, you guys didn't see it because you were probably distracted by the chat. But what? How I messed up was this. This was 2x. It was supposed to be plus x. So I mixed up my negative and my positive there. So what I always say when it comes to math is if you mess up, just learn from your mistake. That way you don't have to make that mistake again. So if you guys rewind, if you're watching this on YouTube and confused about what's going on in the chat, what we're going to do here is I messed up on one of the steps. I thought this was subtracting, and it's supposed to be addition. So that's how come it's 3x. So when I subtracted it, I messed up the sign. So that made things cancel out that weren't supposed to. All right, so going on to the next one. All right, Sammy, make sure you're paying attention to this too, and not just chatting on the chat. I do encourage you guys chatting, but at the same time, make sure you guys are understanding what's going on. All right, so this next thing, we did do this one because I remember this was weird. So this, you can't factor out. If you guys saw my video on dose, this would have to be a squared. And you can't square root this. So if you guys haven't seen that video of that I finished off where I talk about difference of squares, difference of sums, make sure you go back and watch that, especially now that the class is at a slower pace. So I can't simplify this. So I'm going to leave it the same, but I can simplify this bottom. So I'm going to make this into a yellow box. X squared minus 6. So we get that. And this is going to remind me to do a plus x. So I need these to be 2 apart from, or 1 apart from each other to get this negative 6. So I'm going to try a positive 3 and a negative 2. The reason why I do that is if I do this, this becomes negative 2x, this becomes 3x, 3x, negative 2x. When you add these two up, you're going to get a positive x in the middle. So when I rewrite this, I'm going to leave the black the same. I'm going to show my factored form. So now that I have that factored, that's good. I can factor out something from this. They weren't nice like they were over here. This one you can actually do a factored form. I'm going to factor out a 4. And when you do 4x divided by 4, you get x. Negative 16 divided by 4 is negative 4. Going to make my little line here. There's a negative right here. And what I'm going to do now is I'm going to do the green in this little box. So I'm going to do this little box. And this is going to be x squared. This is going to be negative 12. I'm going to have a little reminder of negative x right here. So this is x, x. I want my middle number to be negative. So I know 3 times 4 is 12, but I need to get a negative 12. So I'm going to try negative 4 and 3. The reason why the bigger number is negative is my middle number is negative. If I look right here, that middle number is negative, so I want my bigger number. When I do this, my bigger number needs to be negative. That way when I add these up, I get a negative number. No problem, Julia. What you missed out on, though, is that I'm going to start the class at a slower pace. So we're going to do 1 unit every 2 weeks to try to give everyone a chance to catch up. It also makes it so I don't have to rush through these videos. So when I do this, this right here is going to be x minus 4 parentheses x plus 3. So that I'm getting from here and here. So now what I'm going to do is I notice, hey, look, I can cancel these two out. Can't really do anything here. So what I'm going to do now is, hey, they both have a x plus 3. And I'm going to need this x minus 2 on this side, on this bottom right here. It's kind of missing. So in order to make this easier on me, I'm going to do x squared minus 29 over, I'm going to leave this the same because this has our lowest common multiple. Going to bring my negative sign over. Going to bring down my 4. That didn't cancel out. And I need this x minus 2 over here. So I'm going to do x minus 2. But I can't just do it to the top. I also have to do it to the bottom. So I know you guys want to cross this out, but the reason why we're not crossing it out is we want these two bottoms to be the same. So when I rewrite this, I'm going to leave the bottom as x minus 2, x plus 3. And now on the top, I'm going to bring this negative over. And I'm going to bring over this, I'm going to put it in blue, 4 x minus 2, which is this. And I'm going to bring over my x squared minus 29. So now from here, I'm going to distribute this negative 4. So I get this x squared minus 29. In blue, I have negative 4x plus 8. The reason why it's plus 8 is that negative times a negative is a positive. So from here, the bottom stays the same, x minus 2, x plus 3. If you guys, I do recommend you guys take notes. So if you guys haven't been, it's a good idea to do it, especially now's a terrible time for me to bring it up because I'm about to erase all this. But again, you guys can always watch the YouTube video if you're missing notes. So now what I'm going to do, I'm going to erase these boxes because I've already used these boxes. I'm going to erase this stuff here. I wish there was a way I could just massively erase without having to erase everything. Okay, cool. So we have that. So now what I'm going to do, I am going to simplify this into x squared. Oh, did I erase the part I erased? I totally erased. Oh, no, it is. It's right there. So when I'm doing this, I want to simplify my middle numbers. So if I'm simplifying this, this becomes x squared minus 4x. I'm going to combine this negative 8 and this, or negative 29 and this positive 8, so that ends up being negative 21 over x minus 2, x plus 3. I'm going to see that I can make this into a box. So I'm going to box this up. This is a squared, negative 21. Negative 4x is our reminder. X. I want a negative number in the middle. So I'm going to try negative 7 and positive 3. That makes this negative 7x. Negative 7 times x, negative 7x. X times 3, 3x. Guess what? If I add these two boxes together, I get that middle number. So this means I can rewrite the top as x plus 3, x minus 7. And if you guys have made it this far without falling asleep, congratulations. I know this is tough. I'm sorry. And these would cancel out because they're the same. So that's how come I get this x minus 7, x minus 2. Oh, thank you, Brianna, for giving Julia the question of the day. So this is how we do it. So it is a lot of work. There's a lot of box method going on here. And so just make sure you understand the box method. If you don't, let me know. We can always go over it again. We can go over it during study hall. If you guys are interested in study hall, make sure to send me an email. Email me. It's Victor Beltran at oflschools.org. I know it's similar to yours, but it doesn't have the charter in the middle. So Victor Beltran at OFL Schools. Let me know if you guys are interested in like a study hall to help you guys catch up. And you guys can just ask random questions. It'll be less formal than this. So what we're doing here, this is just talking about how if you're multiplying or dividing, that's why we're able to cancel stuff out. So we should already know this. And then here it's like, well, if we're multiplying, this is really easy because you just multiply straight across. Addition is really hard. Yeah, let me know what time you guys are available for study hall if you guys are interested in study hall. Ooh, it's a fun game. So this becomes a lot easier to simplify when you're multiplying or dividing. An alternative approach is to just multiply straight across. So that's an easier way to do it. So for the most part, I'm not too worried about the multiplying or dividing. I honestly find it easier. The thing we're going to do for dividing, though, is when you're dividing, you're just going to flip the second one over. It's always the second one that gets flipped over. So we can do that with polynomials, too. Remember, polynomials are with this x squared and stuff. And they cancel out. All right. So now moving on to this. So if we're going to do all this, the first thing, this looks super complicated. We want to break it up. So we want to flip it. They want to flip it over first, which I guess is fine. And then they're going to factor it. So if you need to factor it, box method is the way I recommend doing it. And then here we are going to combine them. So since it's multiplying, all we have to do is combine. We don't have to worry about the lowest common denominator here. From here, it's like, hey, look, this matches up with that. That matches up with this. Why don't we just cancel that out with this, cancel this out with that, and it looks a little easier. It doesn't look as bad as this anymore, at least. And this would be an acceptable answer for the test or the activity. So now they want us to, of course, they want us to add them first. Add, subtract, then we're going to multiply and divide. So I'm more excited for these because these are way, way easier. These ones are a little tougher. Again, guys, use your equation editor to show your work. So if I'm going to show my work on this one, what I'm going to do here, I'm going to use my equation editor, copy this problem down. So I have two fractions added to each other. This becomes x over x plus 1. And this is 2 over x. And this is the same thing as saying I want both of them to be the same. So notice here how this has an x at the bottom, but this has an x plus 1. Those are two different things. So what I'm going to have to do here is this first one, I'm going to do as x times x. Oops. Let me put this in a fraction. And then x plus 1 times x plus 2, you make it a fraction, 2 x plus 1 over x plus 1. I know this is weird, but let me show you why it is. Let me use a highlighter right now. What I'm doing is this is this and this. And then this over here is where I'm getting this and this. Otherwise, if you notice, I'm bringing this down here and I'm bringing this right here. So that's all I'm doing for addition. Unfortunately, the bottoms have to be the same. It's the same reason why adding these two requires us to change it to 2, 6 and 3, 6. You have to have these the same. Otherwise, it's really hard to imagine adding a third of a pi plus a half of a pi. You kind of have to have it in sixes to make it easier to add. All right, so our next part here is now that the bottoms are the same, I'm going to write another fraction. It's going to be a single fraction this time. Let me scroll down here. Combining these ideas. So x times x, that's just 2x, right? And I'm going to add that to whatever this positive 2 distributed is going to be. So that's going to be another 2x plus 2. I distributed this part. So this part matches up with this. This is this part right here. Is making sense, guys? Is that a good pace? Cool. And then these bottoms are the same, so I'm just going to leave it the same. They're just kind of written backwards, but I'm going to make it nice and easy here. So I do this. Cool. So now that these are the same, I'm going to want to distribute those. So I'm going to go back up here, make my last, hopefully last fraction. This becomes 4x plus 2. And my bottom, after I distribute this out, is going to be 2x plus x. Or sorry, x squared. X times x is x squared. So I'm going to do this. This is x squared, not 2x. That was my bad. So I'm looking at this and I'm like, oh, you know what? I can probably factor something out here. I can take out a 2 from the top. So that's 2x plus 1. And from the bottom, well, this was my bad. I should have left it like this. That was totally my bad. So I should have never done change that. You kind of want to keep it in factored form until you have your final answer. If I look at that, look, these cancel out. So my final answer, where's the equal sign? Oh, I could just type it on my keyboard. Equals is actually 2. Make it a fraction. If you forget your fraction, guys, you can highlight it and then click the fraction button and it'll automatically put it on top. 2 over x. So all of that work there to get this. So I don't want you guys just putting in the answer, especially on activities, because then this doesn't help. It's not going to help me to know if you guys are understanding it or not. So that's all we had to do there. Shoot. I should have copied some of this down because a lot of the work is going to be the same over here. So this is very similar. That's why I kind of went like, ugh, I done goofed when I did this. So when I copy this down, I'm going to have two fractions, but now I'm going to have a subtraction sign. So this is going to be x plus 1, 2 over x. I want the bottoms to be the same, so this is the part where I'm like, I should have just copied that. In fact, I can kind of do that here. You can highlight the whole thing and then copy, and it kind of makes this easier for when you have to do this part. So again, I'm making my bottoms the same. So in order to do that, I kind of have to take this bottom, this denominator, and multiply it top and bottom by the other one. Oh, I know what you're thinking, like, well, I can just, oops, this should have actually been like this. You can cancel stuff out here, but it's like, you don't want to do that because we need to add these two together. So this, I'm going to distribute here, and this time I'm going to distribute a negative 2x. So this becomes 2x minus 2x minus 2. That's my top part. So again, I forgot to do my fraction, so I'm going to highlight that with my mouse. Click that. Boom, I have a fraction. Now at the bottom, I'm just going to make it look like this because I like this way better. It makes it really easy to distribute. Where's my x? X plus 1. From here, I'm going to simplify this. So you guys can go up and down or left and right. I've been going up and down because it's easier, but you can also put an equal sign to make it easier. Sometimes people like putting like a little arrow. It's whatever you guys prefer. I'm just going to do an equal sign. So this is equal to, these two cancel out, so I end up having this fraction of, where is it? There's a fraction button. Negative 2. And this ends up being x plus 1. And you guys can leave it in factored form if you want. You don't have to distribute it. That was a mistake I made in the first one. Leave it in factored form. That's fine. There's your answer right there. This one, this is my favorite one to do. I like multiplication and division. It's super simple compared to addition and subtraction, which you would think wouldn't be the case, but it is. So much easier. Let me show you why. So I'm going to multiply these. Then I get this 2 over this x. So when I multiply, I just multiply straight across. So I'm not even going to do the up and down thing. I'm just going to go straight across to make it easier for me. Again, you could have done this with the addition, but this is easier to visualize. This is just 2x, 2 times x. This is just x plus 1. I'm literally just multiplying straight across. So if I'm doing that, what I'm going to end up getting here is I want to simplify if I can. So actually, no. Leave it like that. That's it. That's literally all you have to do. Nothing cancels out. It's already in factored form. So that's it. I'll just kick me out twice. I'm so sorry, Julia. Just remember you can always watch the YouTube videos when I release them. So I usually try to release them the same day. So sorry about that. But I do like you guys being here. That way you guys can talk to each other. If you guys need to ask questions. But yeah, or ask me questions if you need to do that. So that one's easy. This next one's a little trickier, but it becomes pretty simple too. So what happens here is I have my two fractions that are going to be multiplied. This is x, oops, that's a z, x plus 1. This is 2, oh wait, not multiplied, divided. Nobody corrected me on that. And this is the same thing. Since you do technically change it, I do usually like writing on the bottom, but this is fine. So now I'm going to switch this to multiplying. So what happens here is the first one stays the same. The second one kind of flipped over. So this turns into an x over 2. You can do that, but like I said, I like doing this because otherwise it makes it look like I'm solving for x. And I don't really like solving for x, so I like it like this. I just wrote it the original way, the other way, that way you guys could see it a little bit better. So now what I'm going to do is I'm going to multiply straight across. So I have x times x. Well, x times x is x squared, right? And then I'm going to have this 2 times x plus 1. This is already in factored form, basically. So this is fine. You can distribute it if you want, but that's kind of what I want for my answer. So my answer is this right here. And I'm going to click OK. So again, guys, I really think you guys should show your work, not just because your teacher might send it back if you don't, but because it's good practice to understand what we're doing here. And then you add and multiply and divide, observe your questions and answer points. What kind of expressions are all of your answers? So all of the answers are polynomials. All of this, again, we're talking about if things close under polynomials. So yeah, they are all polynomials. They are all polynomials. And it's saying are by a system of rational expressions. So these are rational polynomials. So you can say all rational, meaning that they are all some form of division with polynomials. But considering this, what is it closed under? So remember, polynomials were not closed under division. And remember, if you guys remember, I said that sometimes you get these weird polynomials that don't work out. So this right here just says that rational polynomials are closed under division. Division did not close, meaning that if you divided polynomials, you weren't always going to get a polynomial. But if you're dividing rational polynomials, you still get rational polynomials. And here's the explanation right here. Something that's closed means you're going to get the same thing out of it. So for example, integers. You can add integers and get an integer. Integers are whole numbers. You can subtract integers and get an integer. It's still a whole number. You can multiply integers and get an integer. But sometimes when you divide integers, you don't get an integer. So integers are not closed under division. They're closed under this. This is good to go. They're closed under that. You still get an integer. They're closed under this. They're closed under this. They are not always closed under division. All right, so let's move on to this next one. So this next one's just showing us how to do addition and subtraction. So what they're doing here is they're kind of skipping the step where we had to multiply by x on both. So this is like a quick way of showing that everything's closed under division, multiplication, and addition. So that's just demonstrating that they're just not showing you the steps on how they got these results. Polynomial long division. So if you guys haven't done long division, let me know. I can always review it. But long division is just you divide this and you're like, okay, how do I get 7 into 41? If I multiply by 5, I get 35. That's pretty close. Then I subtract, get that 6, bring down the 7. they should really have like little symbols here. They're going to bring down the 7, bring down this 9, and you're always multiplying like this. Oh, I should have done that in a different color. So that's how you do long division. We're going to do that with polynomials right now. So the interesting thing about division is if you have a remainder, so for example, over here, there was a remainder of 49, you would have to go to decimals. But if you have a remainder, you can just write it as a mixed number by taking your remainder, whatever you got as your remainder, and putting it over whatever you were dividing by. So for example, for this one, it would turn into your remainder, which was 49 over 7. Oh, actually, this was not a remainder. They just forgot to finish it. Why didn't you guys finish it? Let's say if you had a remainder, let's pretend this was like 5 or something when I subtracted it. It would be 5 over 7. That's how you get mixed numbers, is there's a remainder, and that remainder goes over your divider. Let me delete this. So that's how you would do that. So they're doing that quick review because now we're going to do long division. So the way we do long division here, we're looking at this x here, and we're trying to get this right here. So what we're going to do here is we have to do x to the fourth, or 4x squared times this. That'll give us this. And we have to subtract. So we're doing the exact same thing. We're still subtracting and all that other stuff. It's just now we're doing it with polynomials. So I have to multiply by this and by this. That's how I get this negative 12 here. Next thing we're going to do is we have to subtract those out. And we're going to keep doing this. So we still have to get this times this to get this. But we also have to distribute it over here to get this. So this is going to take some practice, guys. I'm trying to rush through this because I know we don't have that much time. Get through that. And then, so our answer is this top part with our divisor over, or our remainder over our divisor. So that's how you would do long division. So just so you guys can see it, I'm going to show it over here. So what I'm going to do here, how do I get negative 3x to the fourth? I'm going to have to multiply this x by negative 3 to the third. That'll give me this negative 3x to the fourth. And then once I distribute this, I get this part. Then I'm like, how do I get this from this? Well, that's terrible. They're really similar colors. So I'm going to be like, well, I'm going to multiply it by x squared. And then when I subtract it out, it's like, uh-oh, there was nothing left here. I don't see how they don't have these lined up. Oh my gosh, Edmonton, why are you so bad? This goes here. You're going to bring down this x to the 0. So you always have to have all the polynomials. So notice how they're always including this. Even though there wasn't an x squared in the original, you have to kind of write one in. So they didn't have one, so they wrote it in. And then you're just going to do it just like you would regular division. So this is what you would do. And then I had a remainder of this. So this remainder means that my answer would be this, since it's a positive 27, 27 over my divisor. All right. So that's how you would show your work for this question here. So they kind of just showed it as, hey, just tell us what your remainder is and tell us what you got on the top of that division. That's all they want. So long division in the real world, sometimes we have real equations. It's really hard to imagine these, but sometimes we have equations like, let's say we have a really long equation for, I don't know, like a phone bill. And we're dividing that by, well, we don't know how many roommates we're going to have. It's going to be whatever roommates we have before, and we're hoping to get 2 more. So usually you would plug in the real numbers, but these are kind of ways to do it. Engineers and architects use it a lot more. So it's really hard to kind of give you an example of it since you guys aren't engineers, architects, or scientists. But they want you to learn it now. That way, when you get to this point, you're already familiar with how to use variables. So if you ever guys want to ever study like video game design or engineering and stuff like that, this comes into play a lot. So this is one thing that's happening here. They're trying to give this real world example. We have a cardboard box. And the area of this box is x squared plus 2x minus 15. And we know that the side of the box is x plus 5. We just don't know what this side of the box is. So they want us to do this with long division. So if you guys need to leave right now, that's fine. Just remember to answer the question, what was your favorite game? I'm going to finish this up. So if you guys aren't able to stay for the whole time, that's fine. Just make sure to watch it on YouTube. But I'm going to finish this. Just make sure you guys have answered the question. So I'm going to finish this up. So when I want to do this, I'm essentially want to divide it. I don't know why they gave you this one because you can easily box method this. Oops, 2x goes over here and 15. But let's pretend it didn't work out that way, which it might not. I'm hoping that they do give you a remainder. Otherwise, you could have just box method it. So if I want to do long division, oh no, what was this? Long division is kind of hard to show on this. Is there a division sign? There is not. I'm trying to think on how to do. I'm gonna have to handwrite my work, and you guys might have to take a picture, because so for this one, you guys have to basically show a picture to show your work. So if I'm doing this x plus 5 and I'm dividing it into this, how do I get x squared? Well, that's just x. Okay, cool. So x times x is x squared. Oh, actually, I want to line it up with my x's, so I'm going to write it over here. That's x squared, and then x times positive 5 is 5x. I'm going to subtract this out, so I distribute this negative. So I cancel these out, and I have a negative 5. 2 plus negative 5, so I'm left with negative 3x. I'm going to bring down my 15. So I'm going to multiply this by negative 3. Okay, so then I get negative 3x minus 15. And of course, there's no remainder. So you guys could have easily box method this. I don't know why they didn't give you a remainder, because otherwise doing the box method would have been easier. But this is another way for you guys to be able to do this. If you guys don't like the box method, you can do long division. That's fine. So our answer here was just x minus 3. Now we're going to do this. So now this one, you definitely can't box method it. I mean, you could theoretically box method it by just combining these ideas, do a box method on top, factor by grouping up here, but let's do their long division. So their long division is going to be this x squared plus x minus 6 going into this long one over here, which I apologize. This is a very long problem. So root sign. Oh, we can use a root sign. I mean, I guess we can do that. Do you guys want me to try to do that, or is the handwriting better? I'm not a big fan of doing the root sign because if you do the root sign, it's really hard to line it up. And honestly, I would just do a picture because then you have to do like all this work. I don't think you got. I don't think we had done this one yet with the root. So this one, I recommend just taking a picture of your work because it's going to be really long for you guys to type all that stuff in. And I don't think you guys want to type all of that stuff into the computer. That's too long. But that was a good idea. I was debating on using that root sign, but then I'm like, I'm just going to do it by hand. And you guys can do it on paper. So if I do this, how do I get this x, 2x cubed? Well, I'm going to just multiply it by 2x. So it goes way over here because it's an x. So this becomes 2x cubed, 2x squared. And then this is going to be negative 12x because I'm multiplying it here. So when I do this, I'm going to subtract this out. This cancels. This positive 2 turns into a negative, so this just becomes x squared. This negative right here turns into a positive when I distribute, so this becomes positive x minus 6. So how do I get this x squared? Well, I'm just going to add 1. So this becomes x squared plus x minus, really, again, there's no remainder when I subtract. So your answer is going to be 2x plus 1. I think they're just being nice with you guys, but I'm like, there should really be a remainder so we can actually use that. So do self-evaluation. Again, if you guys need to see all that work, because I know I just deleted it, I'm sorry. Try to do it from the YouTube video. And our summary, we're going to talk about, you can watch the video. It's going to summarize all the stuff we did. I always recommend watching or reading your summary before you take your mastery test. It makes it so much easier, guys. So I'm sorry this session went on longer than it was supposed to. But again, all these sessions are going to be two videos for every tutorial now. So it's going to be a week for every module. If you guys need help catching up, please, please, please make an appointment with me. I will stop the recording.